Ever notice something strange about mirrors? They swap left and right, but somehow don't flip up and down. So what's the mirror really doing? And why does it feel like reality itself is getting twisted? This isn't a trick of glass or a flaw in your eyes. It's a deep idea about space, direction, and how you define left and right in the first place. Once you see it, you can't unsee it, and the mirror never looks the same again. Welcome to the channel where we take big physics ideas and peel them apart with curiosity and common sense. Stick with me till the end because the final insight ties everything together in a beautifully simple way. And if you enjoy physics that makes you think rather than memorize, go ahead and subscribe. There's plenty more mind-bending clarity ahead. Let's start with something wonderfully ordinary, a flat mirror on the wall. Nothing fancy, no tricks, just glass and a shiny coating. And yet, this simple object manages to confuse almost everyone who looks into it. You stand in front of the mirror, raise your right hand, and the person in the mirror raises what looks like their left. So we say very confidently, aha, the mirror flips left and right. But here's the first important move. Let's slow down and ask what the mirror actually does, not what it seems to do. A mirror does one very precise, very boring thing. It reverses depth. That's it. Imagine space as having three directions: left, right, up, down, and forward, backward. The mirror doesn't care about left or right. It doesn't care about up or down. It only reverses the direction perpendicular to its surface, the direction going into the mirror and coming back out. If something is 1 meter in front of the mirror, its image appears 1 meter behind the mirror. Forward becomes backward. Near becomes far. That's the entire operation. Now here's the thought experiment that clears the fog. Suppose you lie down on the floor and slide a mirror above your face, perfectly horizontal. When you look into it, does your reflection look upside down? No, up is still up, down is still down. But now tilt that same mirror and put it on the wall. Suddenly people insist it flips left and right, but notice, the mirror didn't change its behavior. You did. The mirror always flips the direction, pointing straight into it. The confusion comes from how we mentally rotate ourselves to compare with the image, to make sense of the reflection. Your brain imagines another you standing where the image is. But to face you, that imaginary person must turn around, rotate 180 degrees, and that rotation swaps left and right. So the left-right flip isn't caused by the mirror, it's caused by imagining a rotated version of yourself. Here's another everyday analogy. Take a sheet of paper and write the word hello on one side. Now press it flat against a window and look at it from the other side. The word appears reversed, but not because the window flipped left and right. It's because you're now seeing the back of the paper. Front becomes back, inside becomes outside. Mirrors do the same thing. They turn space inside out along one direction. In physics terms, very gently now, the mirror performs a parity inversion along a single axis. It's not a full inversion of space. It's not magic. It's geometry. And this is why mirrors don't swap your head and feet. There's no rotation involved in the reflection itself, just a reversal of depth. Once you see this, the mystery shifts. The mirror stops being strange. Instead, our language becomes the strange part. We talk about left and right as if they're fundamental properties of the universe, but they aren't. They're labels we assign using our bodies, which happen to be symmetric in a very particular way. So the mirror isn't lying to you. It's being perfectly honest, almost annoyingly so. It's showing you exactly what happens when space is reflected across a plane. The real trick is that it exposes how much of reality depends on how we choose to describe it. And that's where things start to get really interesting. Now let's talk about left and right, because this is where things quietly get strange. You probably feel that left and right are obvious features of the universe. Your left hand is your left hand. Your right shoe goes on your right foot. End of story. But physics has an annoying habit of asking obvious to whom. Here's a simple question. If you were floating alone in empty space, no stars, no walls, no mirrors, could you define left and right? Not describe them, not point to them, define them. You could wave your arm, sure, but there's nothing outside of you to compare against. You can define up and down if there's gravity. You can define forward and backward if you're moving, but left and right, those turn out to be surprisingly slippery. This tells us something important. Left and right are not built into nature the way distance or time are. They're relational. They depend on how we choose to label directions. Here's an everyday analogy. Take a glove, say a right-hand glove. You can rotate it any way you want, turn it upside down, spin it around. No matter what you do, it will never fit a left hand. There's a deep asymmetry there. The glove has a handedness. This idea has a name in physics and chemistry: chirality. Objects can be left-handed or right-handed in a way that rotation alone can't fix. Now here's the key point. When you look in a mirror, the mirror doesn't turn you into your opposite chirality. You're still you. Your heart is still on the same side. Your right hand is still your right hand. The mirror hasn't swapped your hands at all. So why does it feel like it has? Because when you compare yourself to the image, you imagine turning around to face it. And that imagined rotation, again, introduces the swap. The labels move, not the physics. This is where human intuition sneaks in. We define left and right using our bodies, which are mostly symmetric front to back, but not left to right internally. We have a front and a back that are very different, but left and right feel interchangeable until we try to reflect them. So when the mirror reverses front and back, our brain tries to fix the situation by rotating the image mentally, and that's when left and right appear to flip. Now here's the really beautiful twist. For a long time, physicists believed nature itself didn't care about left or right. The laws of physics were thought to work exactly the same in a mirror-reflected universe, and mostly they do, but not always. In the mid-20th century, experiments showed that certain subatomic processes, particularly involving particles like neutrinos, do distinguish left from right. Nature at a deep level has a preference. It's subtle, but it's real, which makes our mirror confusion even more interesting. In everyday life, left and right feel deeply human. In fundamental physics, they're almost irrelevant, except in a few rare, precious places where the universe whispers. I do notice the difference. So the mirror isn't playing tricks. It's revealing something about us. How we label space, how we use our bodies to define direction, and how much of obvious reality comes from habit rather than necessity. Once you realize that left and right are not universal facts but human conventions layered on top of physics, the mirror stops being mysterious. Instead, it becomes a lesson in how perception, language, and physical law quietly dance together. Let's clear up a confusion that sits right at the heart of the mirror mystery. Beck, Oss. Once you see this distinction, the whole problem snaps into focus. People often say a mirror turns the world upside down. Others say it flips left and right. Both sound reasonable, and both are wrong in an important way. What a mirror actually does is neither of those. A mirror turns things inside out along one direction. That sounds abstract, so let's build it slowly with something you already understand. Imagine holding a book in your hands. The cover faces forward. Now rotate the book upside down. The top becomes bottom. That's a rotation. Nothing mysterious there. Now rotate it left to right. Same thing, still a rotation. But now imagine something very different. Imagine peeling the front cover off the book and pushing it straight through to the back without rotating it at all. Front becomes back, inside becomes outside. That is not a rotation. That's a reflection. And that difference, rotation versus reflection, is the whole story. Rotations preserve the handedness of objects. Reflections don't. Here's a great everyday test. Take your right hand and try to rotate it in space until it lines up perfectly with your left hand. You can turn it any way you want. You'll never succeed. But if you look at your right hand in a mirror, suddenly it matches the left hand shape. That tells us something deep. The mirror didn't rotate your hand. It reflected it, turning it inside out in one direction. Now let's apply this to space itself. In three-dimensional space, there are three independent directions. A rotation just mixes them around, but a reflection flips one of them while leaving the others alone. For a wall mirror, that flipped direction is front to back. Everything pointing toward the mirror gets reversed. What was in front now appears behind, but left stays left. Up stays up. So why do we experience it as a left-right flip? Because we instinctively imagine rotations when trying to compare things. When you see your reflection, you don't think, that's a depth-inverted version of me. You imagine another person standing there facing you, and to face you, that person has to turn around. That imagined turn, again, introduces a rotation, and that rotation swaps left and right. The mirror didn't do that. Your mental gymnastics did. Here's another analogy. Suppose you draw an arrow on a transparent sheet of plastic. Now flip the sheet over like a page in a book. The arrow reverses direction, but you didn't rotate it in the plane. You flipped it through the sheet. That's reflection. And once you recognize this, a lot of confusion dissolves. The mirror isn't choosing which directions to flip. Geometry already made the choice. There's also a quiet mathematical idea hiding here. In geometry, rotations keep orientation the same. Reflections change orientation. That's why reflections feel wrong or backwards in a way rotations don't. They move you into a fundamentally different configuration. And nature treats these differently too. Some physical laws care about orientation, some don't. Which is why reflections play such a serious role in physics, chemistry, and even particle behavior. So the crucial distinction is this: mirrors do not turn the world upside down. They do not swap left and right. They reverse depth, creating an inside-out version of space. And when our brains try to force that into a rotated picture that feels familiar, we blame the mirror for a crime it didn't commit. Once you see the difference between inside out and upside down, mirrors stop being puzzling objects and start becoming precise teachers of geometry, quietly explaining how space itself works. Now let's bring the mirror a little closer to you, because at this point, the mirror itself is no longer the most interesting part of the story. Up to now, we've talked about geometry and space. But the reason mirrors feel so strange isn't just physics. It's physics filtered through a human brain and a very particular kind of body. Start with this simple fact: your body has a clear front and a clear back. Your face, your eyes, your hands, they all point one way. Front and back are unmistakably different, but left and right, those are almost interchangeable. Your left arm and right arm are mirror images. Same with your legs, your ears, your eyes. From the outside, you're nearly symmetric. This asymmetry, strong front to back, weak left to right, is the key to the illusion. When you look in a mirror, the mirror reverses front and back. Your brain doesn't like that. A person facing backward feels wrong. So without asking permission, your brain performs a quiet mental operation. It imagines turning the reflected person around to face you. That imagined turn fixes the front-back problem, but it creates a new one, because when you rotate a human body to face the opposite direction, left and right swap places. So your brain solves one discomfort by introducing another, and then blames the mirror. Here's a way to catch your brain in the act. Stand in front of a mirror and point to a spot on the mirror with your right hand. The image points with what looks like its left hand. Now don't rotate the image mentally. Don't imagine it turning around. Just think of it as a version of you whose front-back direction is reversed. Suddenly, the left-right mystery evaporates. Nothing flipped except depth. The illusion only appears when you insist on comparing two bodies as if they're facing the same way. Now let's push this a little further. Imagine a creature shaped like an arrow, clearly pointing in one direction, with no left-right symmetry at all. If that creature looked into a mirror, it wouldn't be confused in the same way you are. It would immediately notice the front-back reversal and stop there. Humans are confused because we're too symmetric for our own good. There's also a neurological side to this. Your brain builds a three-dimensional model of the world by stitching together vision, memory, and body awareness. Mirrors force that system into an unusual situation. You see a body that moves exactly like you do, but occupies an impossible position in space. So your brain does what it always does when faced with something odd. It reaches for the closest familiar explanation. That's me, rotated, and once again, rotation sneaks in, and left-right confusion follows. This is why mirrors feel intuitive but misleading. They don't challenge physics. They challenge assumptions your brain makes automatically. There's a beautiful lesson hiding here. The laws of physics don't depend on your body shape. Space doesn't care which way your heart is tilted or which hand you write with. But your experience of physics absolutely does. The mirror exposes the gap between the world as it is and the world as you're wired to interpret it. So when a mirror seems to flip reality, it's not distorting the universe. It's revealing how much of reality is constructed by your body and brain working together. And once you realize that, the mirror stops being an object of confusion and becomes a quiet experiment you carry with you every day, showing just how clever and just how biased human perception can be. Let's end by turning the tables away from the mirror and back onto us. By now, the mirror has lost most of its mystery. It reflects light. It reverses depth. It follows geometry with absolute obedience. No tricks, no preferences, no opinions. So here's the surprising conclusion. The mirror is doing exactly the right thing. If anything is misleading us, it's our intuition. We like to think our everyday understanding of space is reliable. Left, right, front, back. These feel solid, almost built into the universe. But mirrors quietly expose that much of what we call obvious is actually a set of habits we've learned so well that we forget they're habits at all. Think about how you decide what's left and right. You don't consult the laws of physics. You use your body, your writing hand, the side your watch goes on. Your internal map is centered on you. Physics doesn't do that. From the point of view of light rays and geometry, there is no preferred left or right. There is only direction, distance, and orientation. The mirror respects those rules perfectly. It reflects angles exactly. It preserves up and down. It reverses only what must be reversed. The discomfort comes when we try to force the mirror's behavior into OU, our human labeling system. Here's a small thought experiment. Imagine you build a robot that has no concept of left or right, only coordinates. XYZ. You put it in front of a mirror and ask it to describe what's happening. It wouldn't say the mirror flipped me. It would calmly report my Z coordinate has changed sign. No confusion, no paradox. The confusion only appears when you bring in human-centered language. This is a pattern you see all over physics. Nature behaves with clean mathematical consistency. We describe it using words shaped by everyday experience, and sometimes those words fit poorly. The mirror is one of those moments where the mismatch becomes visible. There's also a deeper lesson here about how science works. Good physics often feels strange not because reality is strange, but because our expectations are. The job isn't to force reality to match intuition. It's to refine intuition until it matches reality. Mirrors are excellent teachers in that sense. They don't argue, they don't explain, they just show you the consequences of geometry and light. If you feel puzzled, that's not a failure. It's an invitation. And this way of thinking doesn't stop with mirrors. The same idea appears when we talk about time flowing forward, about simultaneity, about particles behaving like waves. Over and over again, nature says, here is what happens. And we say, but that's not how I pictured it. Physics progresses by trusting what nature does more than how it feels. So when you hear the phrase mirrors flip reality, the truth is almost the opposite. Mirrors are brutally honest. They show reality with less interpretation than almost anything else you interact with. What they really flip is your assumption that perception equals truth. Once you accept that, the mirror becomes something wonderful. Not a trick object, but a quiet demonstration of how careful thinking can peel away confusion and reveal something simple underneath. And that's a habit worth carrying far beyond mirrors. When something seems strange, don't accuse reality. First, check the labels you brought with you. So when we finally step back and look at the whole picture, the mirror turns out to be far less mysterious and far more honest than we first thought. A mirror doesn't flip left and right, and it doesn't turn the world upside down. It does one simple, precise thing. It reverses depth. Everything else, The confusion, the paradox, the feeling that reality has been twisted, comes from how we choose to compare ourselves to what we see. Our brains quietly rotate the image to make it feel familiar. Our bodies, with their left-right symmetry and front-back differences, fill in the rest. And in that gap between clean geometry and human intuition, the illusion is born. The mirror follows the laws of physics perfectly. It's our assumptions about space, direction, and obvious reality that get exposed. That's the real lesson here. Physics isn't about memorizing strange facts. It's about learning when to question what feels obvious. Sometimes the universe isn't being weird at all. Sometimes it's just showing us how we think. If you enjoyed peeling back this everyday mystery and seeing the simple idea hiding underneath, consider subscribing to the channel. We explore physics with clarity, curiosity, and respect for your intelligence, one familiar mystery at a time. Thanks for spending this time with me and thinking through something as ordinary and as sneaky as a mirror. Curiosity like this is how physics stays fun. You notice something simple, ask an honest question, and suddenly the world looks a little clearer than it did before. I really appreciate you being here and sharing that curiosity with me. Until next time, keep asking good questions, and I'll see you in the next video.